Okay, so good day everyone. In the previous video, I have shown you how to convert a certain conditional statement into its converse, inverse, and contrapositive. Now, let us have some interesting na facts about these logical statements. So the first interesting na fact is that the conditional statement P implies Q is not, take note, is not logically equivalent to its converse and inverse. So here's a truth table, and let us discuss it one by one. So we have two variables or two statements, P and Q. Okay, so P and Q can either be true true or true false or false true or false false. So taking the negation of not P, so the if P is true, it becomes false. If true, it becomes false. If false, it becomes true. While the negation of Q, not Q, is true becoming false, false becoming true, true becoming false, and false becoming true. Okay, so what about the conditional or the implication? So from our previous videos, we know that these are the truth values of the conditional. So if both the P and Q are true, then the condition is true. Okay, and if the P is false, regardless of the value of Q, it will be true. And a certain condition will only be false if P is true and Q is false. Okay, so now the converse, on the other hand, you know that the converse is just the swap na role of the P and Q. So in the conditional, the P is the hypothesis and Q is the conclusion. In the converse, the Q is now the conclusion, the hypothesis, and P is now the conclusion. Okay, so taking its truth value, that's determining its truth value. If Q is true and P is false, P is true, I mean, then Q implies P will be true. So it will only be false if the hypothesis is true and its conclusion is false. All right, so that's why we only had a false na truth value for the converse. Okay, so for the inverse is just the negated na values of the P and the Q. So the inverse may be expressed in this notation. If not P, then not Q. Okay, so let us examine the how this was derived. These truth values were derived. So not P implies not Q. So in here, it will only be false if your hypothesis is true and the conclusion is false, and the rest will be true. Okay, what about the contrapositive? The contrapositive is derived from interchanging the roles of the inverse. Okay, so in order to get the contrapositive, you first take the negation of P and Q, or the inverse, and then you swap the not P and the not Q. So we have the not Q implies not P. Okay, so it will only be false if, let's look at the not Q implies not P. So we have, it will only be false if your hypothesis is true and your conclusion is false. That's why we have a false in here and the rest are true. Okay, so our first interesting fact is that the conditional statement is not logically equivalent to its converse and inverse. Okay, so as you can see here, the truth values of the conditional is true, false, true, true. But looking at the converse and the inverse, we can see that they are not equivalent. So for instance, if P is true and the Q is false, the conditional is false while the converse and the inverse will be true. Okay, same is true when the P and Q is false and true. The condition will be true, but the converse and inverse are both false. Okay, and we can see that the conditional statement is logically equivalent to its contrapositive. So if P implies Q, then it is logically equivalent to not Q implies not P. So we can see here it's color coded in green. The truth values of the conditional and the contrapositive are all similar. Okay, if P and Q are true, then conditional and contrapositive are also true. If your conditional is false, then contrapositive is also false. Okay. And lastly, the converse is logically equivalent to the inverse of the original na conditional. Okay. So the converse is logically equivalent to the inverse of the original na conditional statement. Thus, Q implies P is logically equivalent to not P implies not Q. So as you can see here, the truth values of the converse and the inverse are similar. Okay, so let us have an example.